Alright, so last time we started a little bit on section 1.6. I forgot to post a video. I realized that today, so I've got it linked now. Figuring to go there now. If you missed that or just need to go back over any of it. So let's see, what do we say? We're looking like February 10th. Is that what we said on this one? Okay. February 10th. Looking at there. So today we will finish 1.6. We may or may not get started on 1.7. It's a short section. 1.7 is, and really just one topic. And then we got a little bit to talk about circles. I think that's section 1.2. Then we'll be finished with the stuff for test 1. So in 1.6, we've got 3 different types of equations that we're going to deal with. So we spend a long time talking about quadratics, and then now we're looking at some other types of equations we want to be able to solve. And the one we've looked at so far, we looked at radical equations. So we have a variable underneath the square root, and really any index radical. We can use the same strategy, but if we have a radical under a square root, we said we could square both sides. As long as we had the radical by itself on one side. And we can square both sides, that cancels out the radical, and then we can go wherever it leads us from there. So we could get a little linear equation, we could get into a quadratic equation and have to deal with that. But we did mention that if we are raising both sides to an even power, like we are with the square root, we're squaring both sides, then we need to be extra careful to check our solutions. Sometimes we can do everything correctly, but when we plug our solutions in, they may or may not work. Have to be extra careful with those. Let's see. Let's do one more of these. Get this in gear for today. That's a 30. That looks 30 minus 2x underneath the radical, and that equals 2x. Okay. So in this one, we've already got the radical by itself, so we don't have to worry about that part. We can just worry about canceling it out. Okay, so again, it's a square root, so we can square both sides. Okay. So on the left side, the square cancels out the square root, so it just leaves us with 30 minus 2x. On the right side, we have to be a little bit careful when we square. So that means 2x times 2x. That's what that means. So what's that going to give us? 4x squared. 4x squared. So you got to square the 2 and the x. Our rules of exponents, say we have to distribute that power out there to every exponent inside the parentheses. So we got to take 2 squared x squared. And then just look to see what we have left. So here we've got a quadratic again. Okay. It's nice when they turn out to be linear, but sometimes we do get these quadratics involved. So just to make my x squared coefficient stay positive, I'm going to move everything to the right. So I'll keep 4x squared, and I'm going to add 2x to both sides. Subtract 30 from both sides. Okay. and we got to go from there. So what are our choices on the quadratic? We can try to factor if we want to, and we may or may not factor, or we could do quadratic formula, or we could try completing the square. This one's a little messy with completing the square. We didn't really talk about how to do those when we don't have a one coefficient, leading coefficients. I think factoring or quadratic formula probably our best bet here. Either way we go, does anybody notice anything that'll make this one a little easier on us? We can make our numbers a little bit smaller. But yeah, we got a common factor of 2 in there. If we factor out that common factor of 2, you can just jump, like if you're going to do quadratic formula, you can do quadratic formula without doing this. You'll still get the right answer. Now if you do all the steps correctly. Makes our numbers a little smaller. And then here, there's a few ways you can think about getting rid of that 2. It goes away. That's the bottom line. But a couple of ways you can think about what happens to it. We can say we're going to divide both sides by 2. That's one way. So over here, it goes away. And then what would that leave us over on the left side? 0 divided by 2. We're quiet today. What's 0 divided by anything other than 0? So bottom line, the 2 we factor out goes away. So make the numbers a little smaller. So this one would factor. We'd multiply the 2 times the negative 15. We would need factors of negative 30. Give us positive 1. So we could do positive 6 and negative 5. And that will work. I'm going to assume the majority of you would go with quadratic formula here. So we'll do. So A is 2. What's our B? 1. And then C's negative 15. Quadratic formula. We want the opposite of B plus or minus square root of B squared minus 4 times A times C all over 2A. Okay. And we just got to simplify. So 4 times 15 is 60, times 2 is 120, and it's positive because we had 2 negatives in there. That works out nice for us because 121 is a perfect square. What's the square root of 121? 11, yeah, that's a bigger one, so that's okay. So that's 11. So we'll get 2 potential solutions, and we gotta check them. So let's see, if we use the plus sign, what do we get? Negative 1 plus 11 would be 10 over 4. That's 5 over 2. We reduce. Do the minus sign. Negative 1 minus 11 is negative 12 over 4, so that's negative 3. I need to check them because it's possible that one or possibly both of these don't work. I'm gonna copy back down our original down here where we can see it. Ooh. Screen's a little touchy today. So let's see, let's do it in some other color. So it was square root of 30 minus 2x. And that's supposed to equal 2x. So we do have a fraction in there when we're checking the fraction one. But it's not that bad because here 2's will cancel. So we get 30 minus 5 is 25. And that's supposed to equal 5. That checks out. 5 does equal 5. So 5 over 2 is a solution. And if we try negative 3, well, I can tell you right now it's not going to work. That's what are we going to get on the right side? If I get all this crap out of the way. What are we going to get on the right side? We got 2 times negative 3, so that's negative 6. So why do I know that's not going to work? You can do more. You can do more if we need to. So that's 30 plus 6, 36, and we get 6. That's not equal to negative 6. I knew right away it wasn't going to work because we can't get a negative out of a square root. So as soon as I saw the other side was negative something, I know that one's not going to work. So this one, okay, so one solution. There's no new one. Turned out to be a little long, but the new step was not anything bad. We just squared both sides and just kind of stunk because we got a quadratic, so we had to deal with that. Okay. Those are radical functions, and if we had a different index, so if this was a cube root instead of a square root, we would raise both sides to the third power. You just match the index on the radical. And the good thing about that case, it would be raising both sides to an odd number power, so we wouldn't even have to worry about the extraneous solutions. It only happens when we raise both sides to an even power. All right. So second type of other equation, we've got 3 in this section. So the second type is when we have something like this, where we have a higher power of x. So there we're saying we got an exponent bigger than 2. So let's look at one. So something like that. When we start dealing with bigger powers of x, our options become really limited on what techniques we can use to try to solve these. For 3, if we have an exponent of 3, there is actually a general solution like there is for quadratic. So you could say there's such thing as a cubic formula, but it's ugly. And then there is one for you have x to the fourth power. It's super duper ugly. And then it's actually been proven that there's not a general solution for any polynomial equation that has an exponent bigger than 4. So since those formulas are so bad, we're not gonna worry about them. Okay? So we really only have one technique that we're going to talk about. We're trying to solve a polynomial equation like this when you have an exponent bigger than 2. And that technique's factoring. That's factoring. So that actually makes this kind of on the easier side. We don't have a lot of different options to think through. If you see a polynomial equation like this and the exponent's bigger than 2, try to get all the terms on one side, like we have here, and then see what you have in common, factor. So, anything we have in common? Yeah, we got x squared. Yeah, and a 4. Yeah, so we got 4 and x squared we can factor out. So if we take 4x squared out of this one, in the first term, that'll leave us with x. And then leave us with minus 2. Second one. And now, just like before when we factored, it looks a little different because we've got a square in there. But the same property applies. We've got some product. There's some group of numbers multiplied together, and our answer is 0. So the only way that can happen is if one or more of those things is 0. So split it into pieces, split it into separate equations. I'm going to take the 4x and set it equal to 0, 4x squared, and then take the x minus 2, set it equal to 0. The first one might look a little weird, but it's actually easy. We divide both sides by 4, get x squared equals 0, and then square root of 0. That's just 0. We don't even have to remember plus or minus because 0 is not positive or negative. And on the other one, we add 2 to both sides. Get 2 solutions. Not bad. They can look kind of scary when you first see them, but all the ones we're going to have, we're going to work the same kind of method. Factor and set each factor equal to 0. Look at another one. I got x to the 9th equals 36x to the 7th. Anyone like that? Don't panic. Now we're going to get everything on one side first. So I'm going to subtract 36x to the 7th from both sides. And we just look to see if we see anything in common that we can factor out. Do I see anything in common? They both have x's, right, for sure. So we just got to think about how many they have in common. 7, yeah. 7's the most we can take out. That'll leave us 2 with the first one, x squared. And then we took all of them from the second one, so that leaves us minus 36. Here, you may pick up on the fact that the second term is a difference of 2 squares, and that will factor again. That could factor x plus 6, x minus 6. If you don't see that, no big deal. Okay, I'm gonna pretend like I didn't notice. So then what would we do? We take each factor, set it equal to 0. I'll get these two. If you did factor it, you would just have 3 equations here, no big deal. Okay. The first equation, technically what we do to solve it, okay, it's x to the 7th power, so technically we would take the 7th root of both sides. Okay, but it's 0. Okay, so we need something that you can raise to the 7th power and get 0. That's 0. So you could just, if you see that, you can just skip the x equals 0. On the other one, if you're like me and didn't notice that that would factor again, we would add 36 to both sides. And then to get rid of x squared, to get rid of the square, what would we do? Square root, yeah. And if we take the square root of both sides, there's something we got to remember. We had to remember plus minus. There we get two solutions. We get positive 6 and negative 6. And so if we were listing out the solutions, we've got negative 6, 0. Question on that one? Everybody sleepy today? Already on Tuesday? Supposed to get all well rested up over the weekend, so Tuesday you're supposed to still be doing pretty good. You gotta make it over the hump. I'm exhausted today too. I'm with you. Let's look at one more of these, and then we'll talk about our third type. So looks a little different. We've got 3 terms. Thing that should tip us off on how to get started on this is that we've got that exponent of 3, the x cubed term. The first thing we want to look for is to see if we have anything in common we can factor out. Don't see a number we can factor out, but for sure they've all have an x, and the most we can take out is 1. And then we've got some options here. Okay, it really just depends on what you prefer. What we end up with in our parentheses, we have a quadratic. So we've got all those options we talked about with quadratic equations available to us. You could split it up right here and have x equals 0, and then x squared minus 11x plus 24 equals 0, and do quadratic equation on that one to get the other 2 solutions. Just don't lose the x equals 0 one. On this one, it's not too bad to factor the parentheses again. I'm just gonna factor this time. There we need factors of 24. That give us negative 11. So, anybody see them? We got 24, we have a lot of choices. Got 1 and 24, 2 and 12, 4 and 6, no, 3 and 8, 4 and 6. Yeah, 3 and 8 because we can make them both negative, yeah. Okay. And if we do it that way, it's a little shorter than factoring. I mean, shorter than quadratic formula. And because now we just have 3 equations. One's x equals 0. That one's already solved for us. One's x minus 3 equals 0. So x equals 3. And the last one, x minus 8 equals 0. X equals 8. 3 solutions on that one. And you may or may not already know this, but if you're trying to have an idea of how many solutions you're going to have, there's a theorem for that. The short version is whatever the biggest exponent of x you have, that's the maximum number of solutions you can have. So here we had x to the third, so we could have a maximum of 3 solutions. You could have fewer. On the last one we had x to the ninth. We only got 3 solutions. That's okay. You're going to have a maximum of that largest exponent. No questions on those? I'll have to bring some candy or something next time. Get y'all some sugar or something. Though I know math class you don't get, just super fired up about it usually. All right. So last type of other equation, what we're going to call rational equations. And what we mean by rational is when we have a ratio for a fraction. So we don't just call any equation, typically, we don't just call any equation that has a fraction involved a rational equation. Usually we reserve that for when we have a variable in a denominator. Because if you only have variables in the numerators, then you can just rewrite it and you don't have fractions anymore. So let's look at one. This one uses z, so I put a bar through my z's. I may have already mentioned that in here, so you know what that is. Here. So I would call this a rational equation because of that z in the denominator under the 64. Because somehow if I want to get z by itself, somehow I've got to get that variable out of the denominator. Solve for it. Alright, so there are multiple methods you can use on these. You could get a common denominator on the left and then turn that into one fraction and then cross multiply. Okay, that's fine. But I'm going to just focus on getting rid of the fraction part. So anytime I'm solving one of these in here, I'm going to use the same method. Okay? And the method I'm going to use is I'm going to multiply every term by LCD. Okay. That's the least common denominator. Least common denominator. So I want to find the common denominator, preferably the smallest one, the least one, and then multiply every term by that. And the reason why I'm doing that is because when we do that, you'll see that the denominators cancel out. We don't have fractions involved anymore. So the issue with that is we have to think about how to get common denominators when we're dealing with variables. This one's not too bad. We've only got one denominator. Well, that's written. So we've got a 1 under the z and a 1 under the 12, if you want to think about it that way. And then z plus 4 under the 64. So what would our least common denominator be on this one? I only got one denominator that's not a 1. Z plus 4. Yeah, thank you. Z plus 4. Plus 4. So I'm going to multiply every term by z plus 4. Okay. So if you actually write that out, it makes it a little long, but I'm going to write it out just so you can see what's happening. Okay. If you practice these, you can get comfortable where you don't have to write this step out. So my first term was z. I'll multiply that by z plus 4 plus next term was 64 over z plus 4. I'm going to multiply that by z plus 4. Get our LCD out of the way here. And then on the other side of the equal sign, I had 12. I'm going to multiply that by z plus 4. The good thing about doing that is that we're not going to have any variables in denominators anymore. So we'll just go left to right and simplify. So the first term I've got to distribute a z. Get z squared plus 4z. And the second term, this is really what we're after. Okay. We've got z plus 4 on top, z plus 4 on the bottom, so those cancel. And for that term, we've just got plus 64 left. And on the right side, I've got to distribute a 12. So I'll get 12z plus 48. And now we're in a more familiar territory. We just have a quadratic equation left. So I'm going to move everything over to the left side and see where I'm at after that. So my z squared can stay. Then I want to subtract 12z from both sides. So 4z minus 12z, negative 8z. And then 64 minus 48. That's 16, I think. Yeah. Have 0 on the other side. Check this one. It will factor, or you could do quadratic formula, or you could complete the square. Those are all good choices on this one. Which way you want to do it? You want to do quadratic formula? Is that what everybody wants to do? Is that what you would do? Yeah, you can do factor, yeah. Majority quadratic formula. We'll take a vote here. Pressure's on. We're going to try to factor. We're going to do quadratic formula. Complete square. Oh, complete square. You'd be the only one probably in the whole class to try to complete square on that. It works nice. I'll do quadratic here. I'll factor maybe the next one. So here we got z equals the opposite of our b. So our b here is -8, so b plus or minus b squared, here parentheses really help you with the sign, minus 4 times a times c all over 2a. So now let's simplify. Factoring is nicer on this one. So we get 64 there, minus 4 times 16, 64, 2. What's our discriminant going to be? 64 minus 64 is 0. So how many real number answers are we going to get? Do you remember? 1. Because 8 plus or minus 0 is just 8. Get 4. Square root of 0, 0. 8 plus or minus 0 is just 8. 8 divided by 2, 4. If you factor, you get 4 twice. One other thing we need to be careful of, we do need to check something. Okay? So we've got a potential solution of 4. What we need to check, so you can check the whole thing, plug it in and make sure it all works out. That's good. Okay, but we especially need to check that if we put 4 into our denominator for z, that we're okay. So on the second one, 4 plus 4 will give us 8 in the denominator. We're okay there. What would not work, right, is if we got -4 for our answer. Because then if we try to put in -4 plus 4, we get 0 in the denominator. That would be undefined. It wouldn't work. So you have to be careful about that. This one is okay. Yeah, that's the quick check. Yeah, you can do the longer check where you actually plug the whole thing in and make sure you get the same thing on both sides. And you could do, okay, I got 4 plus 64 over 8. That'd be 4 plus 8 is 12. That does equal 12. So take it that way. Yeah. The minimum, you want to check and make sure you don't get 0 in the denominator. That is possible when we multiply through by z plus 4 and make weird things happen. So we can get some of those extraneous solutions, and we don't want to do that. Look at another one. Look at this. Numbers are a little bit big on this one, but we'll make it work. Got a rational function. What's our least common denominator on this one? X plus 160. That's the only denominator we have. That's not a 1. So we're going to multiply both sides by x plus 160. Okay. This one's not bad. You could also think of we're really doing the same thing as if we're cross multiplying on this one. You can still think about it as we're multiplying both sides by the LCD. So on the left side, x plus 160, x plus 160, that's cancel. On the left, we're just left with x squared. Right, we got 80x plus whatever 80 times 160 is. What'd you get? 12,800. A little unfortunate because we've got a quadratic. So we have to deal with these numbers. We can do it. We can do it. I'm gonna move everything to the left. So subtract 80x. Subtract 12,800. 0. So here's where quadratic formula becomes a good choice, in my opinion. Okay? Because I don't know right off the top of my head factors of 12,800 that will give me negative 80. And I don't want to list out all the possible factors to figure it out. You could take some, just wild guesses. Okay. See how close you get. I'm guessing this would factor. Oh, I'll do that though. Okay, so we'll do quadratic. Let's do quadratic. We got a calculator, thank goodness. So hopefully that'll help us. So opposite of b plus or minus b squared minus 4 times a times big ugly c at about 2a. Alright, so let's see where that gets us. 80 squared, 6,400. And it's going to be plus, because we've got two minus signs, 4 times 12,800 is 51,200, and I'm really hoping this comes out to a perfect square. So let's see, add those together, and take the square root. Ah, we're in luck. Get 240. Okay. So apparently 57,600 is 240 squared. Okay. I did not have that one memorized. Okay. It's okay if you don't. So then now, looking like we're going to get two solutions here. So let's see. If we use the plus sign, what do we get? So 80 plus 240 is 320. Divided by 2, so that's 160. Do the minus sign. 80 minus 240 give us negative 160 over 2, so negative 80. And then we need to check. We need to make sure. No, get a 0 in the denominator. We had positive 160, so we're okay. If that had been a negative 160 instead, we would be in trouble. We couldn't use that solution. So it looks like both of these will work. And I won't give you numbers that big on the test. Do another one. Do one where we have more than one denominator. Alright, so on this one, we run into the issue, how do we come up with a common denominator when we've got denominators with variables in there? We're looking for at least common denominator, hopefully. Alright, so strategy we want to take is that we need to make sure all of our denominators are factored. Okay? Make sure there's no factoring we can do with the denominators. The first step here, they're factored, so nothing to worry about there. And then for our LCD, we just go through each denominator and we need to make sure that whatever factors it has are represented in our LCD. So like if I look at the first term, I see I've got a factor of x, so I know I need an x in my LCD. And when I look at the second one, I see I have a factor of x minus 4, so I know I'm going to need a factor of x minus 4 in my LCD. And then the last one's a 1, so I don't have to worry about it. So it turns out that x times x minus 4 is our least common denominator, and we don't have to multiply that out. It's going to be easier for us to leave it factored like that. Word of caution here, it's not always as straightforward as just multiplying the denominators together. Because sometimes if you will always get a common denominator if you multiply all the denominators together, but you don't always get the least common denominator. And we really want the least common denominator here, because if we multiply by some bigger common denominator, it makes things way worse. Okay, the numbers are way bigger, got bigger powers of x involved, and we can get more extraneous solutions we have to deal with. We really want the LCD. We've got it here. Let's multiply by it. Got 12 over x times x minus 4 minus 22 over x minus 4 times x minus 4 plus 4 times x minus 4 equals 0. Since the other side is 0, I'm not going to write down times the LCD. It'll be 0. And then we get to see what all cancels. Okay. So let's see, in the first one, we have an x in the bottom that cancels with the, or x we multiplied by. In the second term, the x minus 4's cancel. And then nothing cancels in the last one because it didn't have a denominator other than 1. So in the first term there, we've just got 12 that we have to distribute. That'll leave us with 12x minus 48. Second term, we just have minus 22x left. That's okay for now. And then in the last one, we've got a 4x. Okay, 4 times x is 4x that we need to distribute. So 4x times x is 4x squared. 4x times negative 4 is negative 16x. 0. So now we can clean up the mess a little. what like terms we can combine. We've got 3 different x terms in there we can put together. Unfortunately, we do get a quadratic. We've got an x squared term in there. That's not always the case. Sometimes you get lucky and you just have an x, not an x squared. Let's see, we've got 12x minus 22x, so that's minus 10, minus 16x, that's minus 26x. We had 4x squared, so I'll put it in front, and minus 48. Huh? Then what? What next? A quadratic. We can jump straight to quadratic formula if we want to deal with bigger numbers. Or we can make the numbers a little smaller on this one. What do you say? Anything? Yeah, we can factor. I wish we could take a 4. 4 won't go into 26 even. We can take a 2. If we could take a 4, it would be awesome. That helps a little bit anyway. And then, however you want to think about it, divide both sides by 2. Okay, the 2's gone. Then if you really want to, we can do quadratic formula there. Or you can try to factor. Let's see. A little bit tough on factoring. We can do. Not horrible, but do quadratic. So opposite of b, plus or minus square root of b squared, minus 4 times a, which is 2, c, which is negative 24, all over 2a, so 2 times 2. Numbers are a little bit big, but they're better than they would have been if we didn't factor that 2 out. So let's see, that's 169, and then 8 times 24, 192, and it's plus because we had 2 minuses there. And then 169 plus 192, 361. And luckily that's a perfect square. That's 13 plus or minus 19 over 4. So what do we get here if we did plus? 13 plus 19, 32 over 4, which is 8. Do the minus, that would be negative 6 over 4, so negative 3 over 2. And then what? Gotta make sure that we're not getting 0 in the denominator anywhere. Negatives are okay, we just can't have 0. We had 8 and negative 3 over 2. Neither one of those numbers will give us 0 in the denominator, so. Both of those work. Okay, go get some caffeine or something. You didn't sign it, that's it today. You have questions, you stretching. You didn't sign the sign-in sheet, it's here on the second table. You can get it on before you head out, okay?